Hello everyone, welcome to this math session. Today we will continue the next part of determinant. In the previous session you have learned what is a determinant and how to expand and find the values of determinants using rows or different columns. You know, determinant is a unique value associated with a matrix, square matrix. So to find, we will say in this session, we will say how to find the determinant value, expanding along other rows and columns, and also we will study the properties of determinants. Okay, so let's see the next example. Example 3. Evaluate delta equals determinant value is 1, 2, 4, minus 1, 3, 0, 4, 1, 0. Look at this. We need to evaluate means find the value of this determinant. It has 3 rows and 3 columns. In the previous session you have learned how to expand along any row or column to find the value of the determinant. Okay, so here you can observe that in the, this is column 1, column 2 and column 3, vertical line is known as column. In the third column there are 2 zeros. Always students expand the determinant along the row or column which has maximum number of zeros. Look at this, it has in the third column C1, C3, we have the maximum number 0, that means 2 zeros are there. So expand the determinant along the third column, expanding along the third column. What do we get? We get delta is equal to, expanding along the third column, we get delta is equal to third column elements. First write the sign, you know the symbols are the pattern. Which pattern you need to apply? Plus, minus, plus, minus, plus, minus, plus, minus, plus. Means diagonally all the elements are positive, other 4 elements are negative. So diagonal elements are positive. So what are the, here you know these 2 diagonals you can write positive values. So 4 becomes positive, then minus, it is plus. So first we write the position signs as plus, minus, plus. Now it is possible to expand. So along the column 3, third column. So third column elements are 4, then 0 and 0. 2 zeros are there. So the expansion is very simple. How to write this? Plus 4. 4 into, plus 4 into. Delete the row and column where this 4 lies. Where is this 4? Is in the first row and third column. Delete that. What are the elements left? Write it as a determinant. So it is determinant of minus 3, minus 1, 3, 4, 1. Okay. So the first element is 4. Taking 4 as plus 4. Delete the row and column where 4 is. 4 elements remaining are minus 1, 3, 4, 1. We write like that. Next, what is the element in the third column? The second element is 0. So minus 0. No need to multiply by any determinant because 0 into any determinant is 0 itself. And the third element plus, the third element is also 0. So we just write 0 and stop there. Now what is the value of delta? Delta is equal to 4 into, you know how to expand the determinant of order 3, order 2 here. So minus 1 into 1 is minus 1, multiply this and multiply minus the product of off diagonal elements, that is minus 4 into 3, 12. So that is 0, which is 4 into minus 13, 4 into minus 13 is minus 52. So delta value is minus 52 is the answer. Okay, please make a note of this. This is expanding along the third column. We got this expanding along the third column. So third column, make a note of the signs, that is plus, minus, plus. So plus 4 into, delete the row and column where 4 is, 4 numbers we got as a determinant, minus 1, 3, 4, 1. The second element is 0, minus 0 plus 0, so it remains 0 itself. So 4 into, cross multiply, minus 1, minus of 4 into 3, 12. So minus 13 into 4 is minus 52. So delta value is 52. This way we get. One more example, students, last example. Evaluate the determinant. Please make a note of this, everyone. Fourth example. Evaluate the determinant. Evaluate the determinant. Evaluate the determinant. Delta equals determinant of 0 sin alpha minus cos alpha minus sin alpha 0 sin beta cos alpha sin minus sin beta 0. Okay, so how will we solve this? Let us take delta is equal to, it is given here, 0 minus sin alpha cos alpha, isn't it? But then sin alpha 0 minus sin beta, and the third element, the third column elements are cos alpha sin beta 0. Okay, so we can expand it along any row or any column. You have learnt how to expand it along the rows, different rows or different columns. Now expanding along R1, row 1. So these three elements, expanding along the first row elements R1. So as you know, the sign can be written as, for the first one, diagonally positive, so plus, here minus, this is plus. So first try the symbols as it is, plus, minus, plus. So diagonally, diagonally positive, other four elements are negative. So the first row elements are plus, minus, plus. Now delta is equal to, first element is 0 plus 0, or just write 0. And what is the second element? Minus, sign is minus, the element is sin alpha, minus sin alpha, into determinant of, delete the row and column where sin alpha lies. So it is first row and second column when we delete, so that we have the elements minus sin alpha, sin beta, cos alpha 0, plus the third element is minus cos alpha, into determinant of, delete the row and column where minus cos alpha is. So it is the first row and third column. When you delete, the elements are minus sin alpha 0, cos alpha, minus sin beta. Now it can be written as, so the first element is 0, therefore delta is equal to 0 minus sin alpha, into, cross multiply students, so minus sin alpha into 0, 0 minus, multiply this, sin beta into cos alpha, cos alpha into sin beta. Here minus cos alpha is there, into, multiply this, sin alpha into, minus sin alpha into sin beta is plus sin alpha sin beta, minus 0 into cos alpha is 0. So what is the value of delta? Delta is equal to minus sin alpha into minus cos alpha sin beta is how much? Positive sin alpha sin beta cos alpha minus, look at this, cos alpha into sin alpha sin beta. So it is minus sin alpha, first I write sin alpha, sin beta, then cos alpha. Look at the two terms. It is plus sin alpha sin beta cos alpha, and this is sin alpha sin beta cos alpha, which is minus in sign. Plus minus we can cancel, therefore delta is equal to 0. The value of delta is 0. So we can expand it, the determinant, along any row or any column, so that final answer we will get the same. Okay, so here we have expanded along the first row. First row elements are, first we write the position signs, plus minus plus. So plus is 0, then minus sin alpha. Delete the row and column where this sin alpha is. First row and second column when you delete, remaining elements are minus sin alpha, sin beta, cos alpha 0. Cross multiply this, expand. Then the third element is position sign is plus, minus cos alpha is written as it is, into determinant of. Delete the row and column where cos alpha minus cos alpha is. In the third column and first row, deleting that, 4 elements so formed. These 4 elements are written as a determinant form, minus sin alpha 0, cos alpha minus sin beta. You know how to expand it now. Sin minus sin alpha into, cross multiply, this is 0, into sin alpha into sin, cos alpha into sin beta is written as it is. Minus, here minus cos alpha, cross multiply, minus sin alpha minus sin beta is plus sin alpha sin beta, 0 into any term is 0 there. So the delta is equal to, this is positive, minus of minus, plus sin alpha sin beta cos alpha, this is minus sin alpha sin beta cos alpha. So one is positive, other is negative, cancel it, the answer is 0, delta value is 0. Please make a note of this, students. Look at this. Note, suppose there is a square matrix, let A be a square matrix which is equal to A, B, C, D. This we will get one result. How to get that? Look at this. A is a square matrix of elements of order 2. That is A, B, C, D are the 4 elements. Now, what is the value of K into A, where K is a constant? We take K as a constant. What is the value of K into A? How will you get the value of K into A? Yes, if where K is a constant. If K is a constant is multiplied to the to any matrix is K into A, we know A, B, C, D. If any constant is multiplied to a matrix, then each element should be multiplied by that K. So K is multiplied to A, K into B, K into C, K into D. So if this will be K into A, K into B, K into C, K into D, where K is a constant. K is a constant. K is a constant. So what do we have? A is a square matrix of order 2, A, B, C, D are the elements, and K into A, K is a constant multiplied to a matrix. So it is a multiplication of a matrix with the scalar K. How to do that? You know that K is multiplied to each element of a matrix, that is Ka, Kb, Kc, Kt. Now these are square matrices, so we can find the value of the determinant, right? So then determinant A equals, A we know, what is the value of determinant A? You know how to expand this. We write first in the form of determinant A, B, C, D. determinant. If you change it in the form of determinant, we can get a single value, unique value for this. What is that? You know, multiply, cross multiplication, A into D, that is AD, minus C into B, BC. So what is determinant A? AD minus BC we got. Also, what is determinant of KA? Determinant of K into A is equal to K into A. We know the matrix KA is K into A, KB, KC, KT. So write it as a determinant. Determinant of KA, KB, KC, KD. Okay. So that, what is the value of this? Determinant of KA equals, cross multiply, KA into KD. How much? K into K is K square, A into D is AD, minus, you know how to cross multiply, the product of minus the product of off diagonal elements. What are the off diagonal elements? KC into KB, that is K square into CB. Look at this, K square is common. Common factor is taken off, K square into AD minus CB. AD minus CB. From this first equation, if you take it as first equation, what is the determinant A value? Determinant of A value is AD minus BC. Take it as first equation. So here we have AD minus BC. What is AD minus BC? Is determinant A. So that from equation 1, we can write determinant of KA equals K square into what is AD minus BC? AD minus BC is determinant A. So K square into determinant A. So very, very important result, students. Determinant of K into A is K square into determinant A, where A is a square matrix of order 2. It is a square matrix of, what is the order of this? Order of A is 2 here. So if the order of a square matrix is 2, then determinant of Ka is equal to K square into determinant A. Where the order of matrix A is 2. So that K into determinant A is K square. Here since the order is 2, it changes to K square into determinant A. If the order is n, if the given matrix A is of order n, what will be the value of K into determinant of Ka? Then the order of, the value of determinant of Ka will be equal to K to the power, what is the order of A? If it is n, K to the power n into determinant A. So very important result. Let A be a square matrix. A be a square matrix of order n. Then determinant of K into A is equal to, the order of A is n. Then determinant of K into A is equal to K to the power n into determinant A. K to the power n into determinant A, where K is a constant. K is a constant. So very important result, students. Please make a note of this. If let A be a square matrix of order n, then determinant of Ka, where K is a constant, determinant of Ka is equal to K to the power n. What is n here? Order of A. Order of a square matrix A. K to the power n into determinant A. K to the power n into determinant A. Please make a note of this. If any square matrix A is given, we can find the determinant of A, and if you multiply a constant K to a matrix A and we find the determinant value, if you want to find the determinant value of this, which can be equated to constant, whatever the constant you have multiplied, K raised to the power n into determinant A. Make a note of this. So using this result, we'll solve few examples. Note down. Example 1. Which was asked in the year 2016 board examination for 1 mark. Okay. So, if A equals, if matrix A is equal to 4, 7, 6, 5. Matrix A is equal to 4, 7, 6, 5. Then matrix find determinant of 3A. 1 mark question. As you know, from this determinant, 1 marks, 2 marks, 4 marks and 5 marks questions are usually asked for the board exam. So, if A matrix A is given, we have to find the determinant of 3A. Okay, so first what you have to find, matrix A is known, right? So, 3 into A, first multiply the constant 3 to the matrix A. So, 3A, after finding 3A, get the determinant of 3A. So, the solution, first find out what is 3A. Matrix A is given. We want to find what is the value of 3 into A. So, multiplication of a matrix with the scalar 3. 3A is equal to 3 times the matrix A. Matrix A is known 4, 7, 6, 5. So, 3 is multiplied to each element here. That is the multiplication of a matrix with the scalar, isn't it? So, matrix is multiplied by a scalar 3. That implies 3A equals, it is a matrix. 3 is multiplied to each element. Matrix 3 into 4, 12. 3 into 7, 21, isn't it? 3 into 6, 18. 3 into 5, 15. We got the matrix 3A. It is a square matrix. You know, every square matrix can be associated with the determinant value. Now find the determinant of 3A. Therefore, determinant of 3A is equal to, whenever you write the determinant, it should be within the vertical bars, vertical lines. So, write the elements as determinant of elements 12, 21, 18, 15. You know how to expand this to get the value of the determinant. Multiply the diagonal elements, product of diagonal elements minus product of diagonal elements, which is equal to 12 into 15 minus 21 into 18. So, 12 into 15, 180 minus 21 into 18, 378. So, 180 minus 378 is minus here 8, 198 minus 198 is the value of determinant A. Okay, so how did we find this? First 3 is multiplied to a matrix. Each element is multiplied by 3. 3 into 4, 12, 3 into 7, 21, 3, 6 3s are 18, 5 3s are 15. Now, we want to find the determinant of 3A. How to read this? Determinant of 3A is equal to, write the determinant form. 12 into 15 is 180 and 21 into 18 is 378. Now, 370 minus 378 plus 180 is minus 198. Minus 198 is the value of determinant of 3A. Make a note of this, students. Question which was asked in the year 2018 board examination. Second example, 2018 board examination for 1 mark. Look at the question. Find the value of x. Find the value of x for which determinant of x to 18x is equal to 6 to 18, 6. Okay, look at this. Here the equation is given of the determinant. Two determinants are equated. You are asked to find the value of x. What is the value of x? It's very simple. Look at this. Which can be written as, that implies. Here we consider the two determinants are equal. So consider solution. Let us consider determinant of x to 18x is equal to 6 to 18, 6. Okay, you know how to expand this. Cross multiply, students, which implies x into x, x square minus 18 into 2, 36 is equal to. Now multiply these two diagonal elements minus of diagonal elements, product of diagonal elements. 6 into 6, 36 minus 18 into 2, 36. Okay, so what do we get? 36 minus 36, 0. So it is x square minus 36 is equal to 0. Yes, what is the value of x? We want to find the value of x. X square is 36. That implies x is equal to, yes, square root of 36. It is plus or minus 6. The value of x is plus or minus 6. See, this was a very simple question which was asked for 1 mark. Okay, so what is the equation? Write as it is. So it is cross multiply. We know how to expand the determinant of order 2. So x square minus 36 here is equal to RHS. What is it? 6 into 6, 36 minus 18 into 2, 36. So 36 minus 36, 0 we have. So x square minus 36 is 0. So x square is 36 is brought to RHS, that is plus 36 minus changed to plus 36. So x value is root of 36 is 6. So we have to write plus or minus 6. Okay. This is also important question. Let us say the third one. If A equals, now down students, if A, matrix A is 1 0 1 0 1 2 0 0 4, then show that determinant of 3A is equal to 27 into determinant A. Determinant of 3A is equal to 27 into determinant A. This is a property which you have taken as a note. 3 times determinant A is equal to 3. Since the determinant of is of order 3, it is 3 to the power 3, that is 27 into determinant A. So what is the formula we had? Determinant of Ka is equal to K to the power n into determinant A. Using the same, but you have to prove this. Alright. So, solution. Look at that. First, matrix A is given. In this LHS, we have determinant of 3A. Determinant of 3A means first you need to multiply 3 to the matrix A, then find the determinant. So, solution. Consider first, according to the question you have to proceed, okay. So, here the question is to find 3 into A. First multiply 3 to the determinant, matrix A, you will get 3A, then get the determinant of this is equal to 27 times determinant A. So first find out determinant A, then multiply 27 to it. Okay, so what is 3A? Consider 3A equals, A value is given, find out 3A. So 3A is 3 times the matrix A. Matrix A here is 1 0 0 0 1 0 1 2 4. 3A. Multiply 3 to each element. You will get 3A here. 3A equals, when you multiply 3 to each element, it is 3 0 3. This is 0. 1 is multiplied to 3. 2 is multiplied by 3. 6 0 0. 4 into 3 12. This is matrix 3A. Now what is LHS? LHS is determinant of 3A. So therefore determinant of 3A is equal to, determinant of 3A is equal to, so this is a matrix 3A, so write it in the form of determinant first. How to change it? Writing them between the vertical bars. So it is 3 0 3 0 3 6 0 0 12. Only after changing in the form of determinant, writing in the form of determinant, you please expand, students. As it is matrix, don't try to expand this, because this is just a representation or arrangement of numbers. Now change it to determinant, then we can assign a value to it. Okay, so we can expand it along a row or column which has maximum number of zeros. Which row has maximum number of zeros, or column? Look at this. Column 1 has 2 zeros. So we will expand it along the first column. So right there, expanding along the first column. Expanding along the first column. So right here plus minus plus, because diagonally positive, 4 other elements are negative. So determinant of 3A equals, yes, how will expand? Plus 3 into, delete the row and column where 3 is, remaining elements 3 6 0 12. Okay, now the second element is 0, since this minus 0 have written, plus the third element is also 0. So only you have to find this determinant value, other 2 elements are zeros here. So that, which is equal to 3 into, cross multiply, 3 into 12, 36, 39 means 6 minus 0, yes. 3 into 36 minus 0, which is 108, which is the value of determinant of 3A. Take it as first equation. So LHS we got, determinant of 3A is how much? 3 into 36, that is 108. Determinant of 3A is 108. Now, what is the value of, is it equal to 27 times the determinant A? That we have to find now. What is the value of RHS? So, now consider what is the value of determinant of A. Then we multiply it with 27. Determinant of A is, the matrix A is given, write it in the determinant form, 1 0 1 0 1 2 0 0 4, which implies determinant A is, here also the first column has maximum number of zeros. So column 1 we will expand it along column 1, expanding along column 1, expanding along C1, column 1, we write this as, so write the symbol plus minus plus, so it is plus 1 into, delete the row and column where 1 is, these 4 elements are written as a determinant value of 1 2 0 4, then the second element is minus 0 plus 0, that turns to 0 itself. Therefore, what is determinant A? Equals 1 into, cross multiply, 1 into 4 is 4, minus of diagonal elements when you multiply, it is 0 into 2 is 0. So what is the value of determinant? Determinant A is equal to 4. Now what is RHS? RHS is 27 points. So 27 into determinant A. Therefore 27 into determinant A equals 27. Determinant A value we got it as 4. So 27 into 4, how much, students? It must be 108. So 27 into determinant A is 108. So this is the second equation. Look at the first and second equation. Determinant of 3A is 108. 27 points times determinant A is also 108. So that from equation 1 and 2 we write, from equation 1 and 2 we have, what is that? Determinant of 3A is equal to 27 times determinant A. Hence the proof. Hence we proved it. So, well, for determinant matrix A is given, we have to show 3 times determinant of 3A is equal to 27 point determinant times determinant A. Isn't it same like K? Determinant of K is K to the power n into determinant A. Same like that, isn't it? So here 3A equals, the constant is 3 to the power, the given matrix is of order 3. So n is also 3 here into determinant A. Same thing, that is determinant of 3A is equal to 27 into determinant A. That is what we proved. It's the same conclusion what you have taken before. The same one we have proved using example. Okay. So 3 into matrix A we found. Then find the determinant of this. Expanding along the first column is very simple as it has 2 zeros in the first column. So expanding along first column, we have 3 into, delete the row and column where 3 lies. 3, 6, 0, 12 is 3 into 12, 36 minus 0. So 3 into 36 is 108, that is LHS. Now RHS, we have to get 27 times the determinant A. Determinant A first find out, expanding along the first column here again. 1 into cross multiply elements of the determinant 1, 2, 0, 4. Deleting the first row and first column, we got the 4 elements 1, 2, 0, 4. So cross multiplying, we get the determinant A value as 4. Now RHS is 27 times determinant A. 27 into determinant A is 27 into 4, that is 108. So both are equal here. Determinant of 3A is equal to 27 times determinant A. Okay. Make a note of this, students. Next, we will see few properties of determinants. There are exactly 6 properties of determinants which you have to remember. It's also important for your competitive exams also. So, what are these 6 properties? We will study next. Write down the properties of determinants. Properties of determinants. Properties of determinants. Okay. We will see one by one all the properties. Okay. So the first property, what is the first property? Before proving the first property, we just discuss what is it. We'll see some small example and check what is the property, then we will prove it. Okay, we will verify it later. So the first property states that for any determinant, suppose the determinant A is given. What is the value of determinant A? We know. What if you interchange the rows and columns? What will be the value of the determinant if you interchange the rows and columns? Even if you interchange the rows and columns, the value of the determinant remains the same. That is what the first property. So what is the first property? So let us take the example. Let determinant A is, or you can even say delta. Okay. So delta is equal to, if you name it as 1, 2, 3, 4. Alright? Now, what is the value of this? We know it's very simple. Product of diagonal elements 1 into 4, 4 minus product of off diagonal elements 6 into 3 into 2, 6, which is equal to 4 minus 6 is minus 2. Minus 2 is the value. Now, what if you interchange the rows and columns? You know here 1 and 2 are in the first row elements, are the first row elements. Now, let us consider delta 1 is a determinant obtained by interchanging the rows and columns. So, the first row changed to first column, 1, 2 in the first row, right? We will write it in the first column, 1, 2. The second row elements, 3 and 4, we write it in the second column, 3 and 4. Okay. Now, we got one more determinant. In which way we got? Interchanging the rows and columns. First row changed to first column, second row changed to the second column. So, when you interchange the rows and columns, now cross multiply, tell the value of this determinant, students. Delta 1 equals 1 into 4, 4 minus 3 2s are 6. How much? Again we get minus 2. There is no change in the value of the determinant if you interchange the rows and columns. So, make a note of this. If in the given determinant, if you interchange the rows and columns, then the value of the determinant remains the same. Same value we will get. Even if you interchange the rows and columns of a determinant, the value of the determinant will not change. It will remains the same. So, that is what the first property. Okay. So, after knowing the example, property 1, first one, you can make a note of the statement. If the rows and columns are interchanged in a determinant, if the rows and columns are interchanged, the value of the determinant remains the same. That is the first property. Make a note of this. If the rows and columns of the determinant are interchanged, then the value of the determinant remains the same. Remains the same. Okay. Value of the determinant remains the same even if you interchange the rows and columns. You can verify this. Verification. Okay. So, first we will assume let delta be the determinant. Generally we write it as A1, A2, A3, B1, B2, B3, C1, C2, C3. We write it generally as delta is equal to the determinant of order 3. First make a note of a determinant of order 3. You know how to expand it. Expanding along the first row. What do we get? We write that. Expanding along the first row, along row 1, R1, expanding along the first row. Here is the first row. These are the elements. When you expand it, we write it as plus, minus, plus. We can expand this as delta is equal to, look at this, A1 into, first element is A1, plus A1. Delete the row and column where A1 is. What are the 4 elements? Write it as a determinant form. A1 into B2, B3, C2, C3 is a first term. Now the second element in the first row is A2, but its sign is minus, so we write minus A2 into, what is the determinant? Delete the row and column where A2 is. A2 is in the first row and second column. So the four elements are B1, C1, B3, C3. So delete this term. Remaining elements are B1, B3, C1, C3. B1, B3, C1, C3 plus third element is A3. A3 into, delete the first row and the third column. What are the remaining elements? B1, B2, C1, C2. B1, B2, C1, C2. Now we know we can expand this. That implies delta is equal to A1 into B2, C3 minus B3, C2 minus A2 into, cross multiply students. When you cross multiply, it is B1 C3 minus B3 C1. Usually we take it as a cyclic manner of A, B, C. If it is C1 B3, instead of that we write B3 C1, B after that C. Okay, so plus the next one A3 into, cross multiply, B1 C2 minus B2 C1. Take this as first equation. Okay, so here we have the value of delta. Now what is our statement? What if you interchange the rows and columns? Now interchange the rows and columns. Let delta 1 be a determinant obtained by interchanging the rows and columns of delta. Interchanging the rows and columns of delta. So we write delta 1 as interchanging the rows and columns of delta. We write therefore delta 1 equals, yes, the first row changed to first column, A1, A2, A3. Second row, write it as second column, B1, B2, B3. Third row, write it as third column, C1, C2, C3. Now, can we expand it? Since, look at this, A1, A2, A3 are outside the factors, so we will expand it along the first column, students. First column. If we expand it along the first column, what do we have? C1 plus minus plus. First you write it as plus minus plus. Now expand it, expanding along first column, what do we get? First element is A1 into determinant of, leave the row and column where A1 is. These four elements we write B2, C2, B3, C3 minus second element is A2 into determinant of, leave the row and column, delete or exclude the rows and columns where A2 is. A2 is in the second row and first column. Exclude that. Remaining elements are B1, C1, B3, C3 plus third element is A3 into, delete the row and column where A3 is. A3 is in the third row and first column. Exclude that. Remaining elements are B1, C1, B2, C2. Now, what is the value of delta 1? Delta 1 equals, expand this, A1 into, multiply, the cross multiplication we know, B2 C3 minus B3 C2 minus A2 into, here when you cross multiply, what do we get, students? Note down, B1 C3 minus B3 C1 plus finally A3 into, here cross multiply, B1 C2 minus B2 C1. Just observe this, take it as second equation. Observe equation 1 and 2 Are they same? Look at this. A1 into B2C3 minus B3C2 minus A2 into B1C3 minus B3C1 plus A3 into B1 B2C1. Yes, from equation 1 and 2 we have delta is equal to delta 1. What do you mean by that? Even if you interchange the rows and columns, the value of the determinant is unchanged. The value of the determinant remains the same even if you interchange the rows and columns. Second property. See, the second property is, what if you interchange only any two rows or any two columns? The first one you have seen while interchanging all the rows and columns. Now, any two rows if we interchange, what will be the value of the determinant? For example, look at this. Let us take delta is equal to 1, 0, 0, 2, 3, 4, 5, 6, 7. Okay. So, here is a determinant of order 3. When you expand it, what do we get? Expanding along the first column, because in the first column, the two zeros are there, maximum zeros are there. So, expanding along the first column, expanding along C1, first column, we have delta equals, say, first write plus minus plus the signs as it is. So, 1 into, delete the row and column where 1 is the 4 elements so formed, write it as the determinant 6, 7. Then the remaining elements are minus 0, minus plus 0. So, others are zeros. We don't want that. Only this much. So, what is delta here? Delta is equal to cross multiply 1 into 28 minus 5 into 6, 30. How much is this? 28 minus 30 is minus 2. So, delta is equal to minus 2. Now, what if we interchange the two rows or two columns? Interchanging the two rows are written as, let us consider R1, we interchange R1 and R3, row 1 and row 3 if you interchange. Row 1 and row 3 if you interchange, R1 interchange to R3. See how to write this, please make a note of this. R1 and R3 are interchanged, two arrows. Through two arrows you have to show this. What do you mean by this? What is the meaning? R1 interchange to R3, R1 change to R3, R3 change to R1. All the elements you have to interchange. So, let delta 1 equals, delta 1 is, okay, so 1, 2, 3 comes to R3, 0, 6, 7 goes to R1. So, 0, 6, 7, 1, 2, 3. R2 remains the same, 0, 4, 5 as it is. How did we do this? R1 change to R3, 1, 2, 3. R3, 0, 6, 7 change to R1, 0, 6, 7. R2, 0, 4, 5 remains the same. Now again you can expand along the first column, expanding along C1, first column. We can write this as plus minus plus, delta 1 is equal to, first two are zeros, third element is 1, 1 into, delete the row and column or exclude the row and column where 1 lies. So, the remaining elements are 6, 7, 4, 5, isn't it? 6, 7, 4, 5. Now, what is the value of this delta 1? Is equal to, cross multiply 1 into 30 minus 4 7s are 28. What is the value of delta 1? Delta 1 is equal to plus 2. Look at this. Delta is minus 2 and delta 1 is plus 2. So, what happened here? If you interchange any two rows or any two columns, then the sign of the determinant changes. Delta is, we got delta as minus 2 and interchange the R1 and R3, 2 rows, we got delta 1 is equal to plus 2. Plus 2. One is minus, other is plus. So what does this indicate? If you interchange the 2 rows or 2 columns, then the sign of the determinant changes. That is our second property, students. Please make a note of this. Second property states, write on the second property, if any 2 rows or any 2 columns, if any 2 rows or columns, it is understood. You can even interchange the columns also. Any 2 rows or columns are interchanged, then what happens? The sign of the determinant changes. The sign of the determinant changes. Sign of the determinant changes. Okay, we will verify this taking the same way how we did the previous, how we verified the previous property. Verification. Verification. Now, let us assume delta given determinant as the same way A1, A2, A3, B1, B2, B3, C1, C2, C3. Let us take the determinant as delta. Expand it along the first row, students. First row. Expand it along R1. Okay. So, expanding along R1. What do we get? When you expand it along R1, delta is equal to, so first element is here, first we write plus, minus, plus. How you did the same previous property, how did you expand the same way here? A1 into determinant of B2, B3, C2, C3 minus A2 into, delete the row, first row, second column. What are the elements? B1, B3, C1, C3 plus last element A3 into, here plus sign, A3 into, delete the first row and third column. What are the elements? B1, B2, C1, C2. Okay, so therefore delta is equal to, you know how to expand, cross multiply. So A1 into B2 C3 minus B3 C2 minus A2 into, cross multiply the students, B1 C3 minus B3 C1 plus this one A3 into, cross multiply, B1 C2 minus B2 C1. Take it as first equation. Alright. Now, we have to interchange any 2 rows. What can we do? Interchange this R1 and R3. R1 and R3, this is row 1, row 2, row 3. Let delta 1 is a determinant obtained by interchanging R1 and R3. Let delta 1 be obtained by interchanging R1 and R3. R1 and R3. So, what is delta 1? You have to write R1 interchange to R3 as R1 interchange to R3. How to read this, students? R1 interchange to R3. If the 2 arrows are, this indicate R1 interchange to R3. So, delta 1 equals, interchange this. R1 and R2, R3 are interchanged. First you have to write R3. C1, C2, C3. Second row remains the same. B1, B2, B3. First row comes to the third row. A1, A2, A3. Now, we will expand it along the third row, students, because you have to get A1, A2, A3 outside. to compare it with first equation, we need to get A1, A2, A3 first. So expanding along the third row, expanding along third row is R3. R3. What do we get? Delta 1s. Delta 1 equals. Okay. So it is plus minus plus. So A1 plus A1 into expand, delete the row and column where A1 is. Remaining elements are C2, C3, B2, B3. Minus A2 into second column and third row when you delete. What are the elements remaining? C1, C3, B1, B3. Plus third element is A3 into. Delete the third row and third column. A3 is in the third row and third column. Delete that. What is remaining? C1, C2, B1, B2. Now expand it, students. Equate it with equation 1. What is the relation? We have to get delta 1 is equal to minus delta, right? That we have seen in the example. So delta 1 is equal to A1 cross multiply B3 C2 minus B2 C3 minus A2 cross multiplication B3 C1 minus B1 C3, always write B first then C, plus A3 into cross multiply the students B2 C1 minus B1 C2. Okay. Now look at these two. Here B2 C3 is first, here B3 C2 is first. These two are interchanged here. So take minus sign out from each term. Take minus sign out. So when you take out minus sign, implies delta 1 is equal to, take minus sign out, it is minus A1 into, when you take minus sign out, this becomes positive, minus turns to positive, plus turns to negative. So it is B2 C3 minus B3 C2. Minus sign is taken out, so it is plus A2 into, minus sign is taken out. This is positive, B1 C3 minus B3 C1. Here again minus sign is taken out, it is minus A3 into B1 C2 minus B2 C1. B2 C1. Okay. Now, this is similar to equation 1, but the signs are opposite. So take the minus sign out. Therefore, delta 1 equals minus of, what is that? A1 into B2 C3 minus B3 C1, B3 C2 plus minus A2 into B1 C3 minus B3 C1 plus A3 into B1 C2 minus B2 C1. Since the minus sign is taken out, all the signs are changed. Now equate equation 1 and this take it as equation 2. Equating from equation 1 and 2, compare 1 and 2, equation 1 is delta equals, all the terms which are inside the square bracket, the same terms are here. So delta 1 is equal to minus of, what is the term inside the bracket here? It is same like delta. This term is in the bracket. So it is minus of delta. Delta 1 is equal to minus delta. Means if you interchange any two rows or any two columns, the sign of the determinant changes. Delta 1, when you interchange the two rows R1 and R3, we got delta 1. What is the value of delta 1? Is equal to minus of the given determinant, delta. Okay, so this is the second property. So you have learnt two properties. Now further 4 more properties are left that we will continue in the next session, students. So in this session you have seen how to expand the determinants using the third row and other columns. You will get a unique value always. And also we have seen the properties of determinants. First two properties. First property states, even if you interchange the rows and columns, the value of the determinant remains the same. And the second property states that any two rows or any two columns of a determinant are interchanged, then the sign of the determinant changes. Okay. So further we'll continue in the next session. Thank you.